Greetings and welcome to the Astronomy Picture of the Day podcast. Today's picture is titled the Vela Supernova Remnant. So what do we see here? Well, here we see a very long exposure of a portion of the sky toward the constellation of Vela. And it is looking at a supernova remnant. So about 12,000 years ago at this location, a star would have been seen to explode in the sky. And what that means is that we would have seen a star get incredibly bright for a period of time, for a few months. In fact, some supernovae, depending on the conditions, could be visible during the day. Now we're seeing what's happened over those 12,000 years here. When a supernova like this goes off, the core of the star collapses downward, everything rushes in and then rebounds out, exploding outward. And that material now sends shock waves through the interstellar medium. And even 12,000 years later, it still energizes that material as it travels through the interstellar medium. So all of these shock waves that we see in the center are regions where material is expanding outward. We see it mostly when it hits portions of the interstellar medium which are a bit denser. And that is where they become energized and start to glow. So normally the gas is traveling out, not super visible. But here, once they strike other material, they become quite visible and we're easily able to see them. Now, this is a very long exposure, taking 60 hours worth of exposures, putting that all together to allow us to see finer detail than we could ever possibly see with just our eyes looking through, say, a telescope. That brings out far more detail. We look at two different colors here. We see the red, which is hydrogen gas, and the bluer color, which is oxygen, which is being energized as well. And studying that can tell us about the properties as to what happened when this star exploded 12,000 years ago. We know that this was what is known as a type 2 supernova. That is at the end of the life of a massive star. So there are two specific types of supernovae. One is a collapsed star that explodes. That's known as a type 1. And a type 2 is a star very much more massive than our own sun that reaches the end of its life. And at the core left behind is what is known as a neutron star, a dense core of a star as dense as an atomic nucleus, nearly infinitely denser than anything we know here on Earth. And it spins very rapidly. And that means that this neutron star is also visible as a pulsar, an object the size of a city, spinning about 10 times every second. And it takes something that small and that dense to be able to hold up to that kind of rotation without ripping itself apart. If we tried to spin Earth 10 times a second, it would tear itself apart. Same thing with our sun or most other objects. Most other large objects would rip themselves apart. But these are so dense that they can spin 10 times a second or even more and still hold together. So that was our picture of the day, titled the Vela Supernova Remnant. We'll be back again tomorrow for the next picture. So until then, have a great day, everyone, and I will see you in class.